Good morning, students. Welcome to the online classes. We'll continue the previous chapter. In the previous class, we had discussed about the computer and the different types of computers. Now, today we'll discuss about the different computer languages. First, we'll discuss about what is computer languages. We all know that it is difficult to understand the computer language directly by any user. In the same way, for computer, it is difficult to understand the human language. So, a computer language is required, which is a way to give instructions to a computer to perform the desired tasks. Mainly, the computer language is categorized into two different languages. The first one is the low level languages, and the second is high level languages. Now, the low level languages gives instruction to the computer in a way which is easily understood by the hardware of the computer. These languages are easier for computer to understand, but it is difficult for a human to understand. We cannot understand low level languages. Again, there are two different types of low level languages. The first one is the machine language and second one is the assembly language. We'll discuss the machine language and assembly language later. Second one is the high level languages. These languages give instruction in a natural languages like English. Thus, these are easier for human to understand but difficult for a computer to understand. Now, again, the problem is then how the computer will understand the high level languages. So, for that, these high level languages are required to be converted into the low level languages. About that, we'll discuss the later in this class. Now we'll see the how computer languages are evolved. The first generation language, which is also known as a machine languages. Computer were given instruction in the forms of ones and zeros. That means computer only understands the combination of zeros and ones, which is known as a machine language. The computer was able to understand it directly without any conversion. This language is also called a binary language because there are only two symbols, 1 and 0, and bi means 2. So, this is also called the binary language. Now we will see the different features of machine language. The first one, all these codes which are written in a machine language, it is a combination of zeros and ones. That is a binary language. Binary codes for machine instructions can run directly on the hardware. No conversion is required for the binary codes because we already know that it is a machine language. Machine language also depends upon the different processors of a computer. Thus, for the different processor, machine codes will be different. That means if a system has a i3 processor, then for that machine code will be different. And again, if the system has a i7 processor, then for that also the machine language is different. Now the second generation language, which is also known as the assembly language. In this language, instructions were replaced with some coded terms, which is also called mnemonics. For example, add, hold, sub. These all are the different mnemonics which are used in the assembly language. A computer can understand and work on machine code only. So, the assembly language or the assembly code are needed to convert into the machine language, and the software which is used to convert the assembly language into the machine language is known as assembler. Now we'll see the features of assembly language. The first one, it uses mnemonic codes to represent the machine instructions. It is also a type of low level language. It cannot run directly on the hardware, so we require some assembler software which converts the assembly language into the machine language first. The next is the third generation language, which is also known as the high level languages. First two generation of languages were comparatively easy for the computer to understand, but it was very difficult for a human to read, understand, and code in them. Thus, an English like language came, which is also known as the programming languages, which is used to give the instructions to the computer. This type of languages are known as the high level languages. For example, C, C++, Java, these all are the high level languages. The different features of high level languages are: first, it uses English like words. It cannot run directly on the computer hardware. It requires a translator to translate the high level language to machine level language. The next, it requires a coding for the detailed procedures of how the task is to be done. So, if you want to write any coding in the high level languages, then a complete coding will be required, that what should be the input, how the processing will be done on the input data, and what is the output to be generated for the user's requirement. Next is the fourth generation language. The third generation language require detailed procedure, but a fourth generation language require just what do you want from the code rather than how to do. The example of the first generation language, it is the SQL, which stands for the structured query language. In this, no detailed program is required. You can simply write a one line command to perform any actions or a procedure. Now let's see the different features of fourth generation languages. Codes written in a fourth generation language are very compact. That means they are mainly of one or two lines and no detailed procedure is required. The second, in this, we have to mention what is required to be specified, not the detailed procedure about how it is to be done. The fifth generation languages are more focused on the artificial intelligence implementation. That means the computer should also decide by itself that how to perform different operations. For example, Prolog, OPS5, Mercury, these all are the different examples of the fifth generation language. Still, the scientists they are working on the fifth generation language. Now let's see the features of fifth generation language. The first, they are specially focused upon the artificial intelligence functionality as we discussed. The second, they are more like a natural language. That means this kind of coding will be easy once these languages are developed properly. Still, the scientists are working on the fifth generation languages. We have discussed about the different languages of the computer. Now we'll discuss about the different language translator which are required for the properly functioning of a computer. A language translator is a software that translates one programming language into the machine level language. Mainly, there are three different types of the language translators. The first one is the compiler, then interpreter, and the last one is the assembler. A compiler is a software that converts a program code into the machine code in one go. An interpreter is a software that converts a program code into the machine code line by line. This is the main difference between the compiler and the interpreter. The other differences of the compiler and interpreter we'll see after this. The next one is the assembler. This language translator is designed to translate the assembly language code into the machine language. So the assembly language code can run easily on any machine. Now we'll see the difference between the compiler and the interpreter. The first one, a compiler converts the program into the machine language code directly in one go, while the interpreter converts a single instruction at a time and it converts the program line by line. In a compiler, if there are some errors in our program, then the list of error with the line number is generated once the full program is checked, while in the interpreter the errors are generated for one instructions at a time. In interpreter the program will run line by line. If we are using a compiler, then the full program will run after the compilation of complete program, while in the interpreter the code will run line by line. If we are using a compiler, then once the compilation is done, after that, if we are not making any changes in the code, then compiler is not required. While if we are using interpreter, then interpreter will be required for each and every line every times we compile the program, as interpreter converts the program one by one, that is line by line. Now here are some homework questions. Answer of each and every questions are already given in the video. With this, we complete the chapter. Thank you and stay safe.